Okay, so welcome back to our video lesson in grade 10 mathematics. So for this video, we will discuss the module 5, the proving theorems related to chords, arcs, central angles, and inscribed angles. Okay, so I hope you are seated in a comfortable place and you are holding your module with your notebook and also your to-do list. Okay, so I am Ronald Fernandez. Together with me are other math teachers in grade 10. We have Mom Arianti Salisi and Mom Pap B. Ladera. Okay, let's start. So lesson 1, that is theorems related to central angles and their corresponding arcs. So we have definition of congruent circles and congruent arcs. We already discussed this in our module 4. So congruent circles are circles with congruent radii, meaning if two chords, if two radii or two radius are equal, meaning the two circles are also congruent. Okay, arcs in the same circle or in congruent circles will have the same measures are called congruent arcs. Okay, for example, we have in circle Q and your WX and YZ. Yes, WX and YZ in circle Q is congruent to circle T, then we have WX and SR are congruent. Okay, since they are okay. If the two circles are congruent, it follows that the arcs are also congruent. So theorems on central angle and arc. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Example 1, in circle X, angle AXB, meaning AXB is congruent to angle CXD. Okay, so the minor arcs, the intercept are also congruent since the two central angles are congruent. So therefore, what's the measure of this? This is 60 degrees, no? We have already discussed this theorem, 60 degrees also. So they are congruent. So lesson 2, theorems related to chords and their corresponding arcs and a chord perpendicular to the diameter. Okay, these theorems, the proving of these theorems are already in your module, so you can explore how these theorems are proven. So in a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So in circle X, above, the chord MN is congruent to OP. Since the chords are congruent, it follows that the arc MN and the arc OP are also congruent. If circle X and circle Y are congruent, then it follows that MN and OP and WZ are congruent, the same with their arcs. Okay, so in a circle, a diameter bisects a chord and arc with the same endpoints if and only if it's perpendicular to chord. Okay, so we already discussed this now. If this is the diameter and it bisects the chord, it, uh, it follows that it is perpendicular to the chord. Okay, meaning this portion here, the QV is equal also to this is VRV. Okay, so lesson 3, proving theorems on inscribed angle intercepted arc. These are more on proving, no? If an angle is inscribed in a circle, the measure of the inscribed angle is equal to 1/2 the measure of its intercepted arc. So we already discussed this. So for example, if BAC is 85, what's the measure of arc BC? This is twice of 85 is 170 degrees. Okay. Example 2. We have solved for x if HGI meaning this one is 25 degrees. and your arc HI is 4x plus 2. Okay, so we all know that to get HGI, the measure of, don't mind the solution, HGI is equal to 1/2 of the measure of arc HI, right? Diba? To get this angle, dapat half of this arc. So what is HGI? It's given, so that is 25 degrees. Just substitute. HI is 4x plus 2. Okay? Then you have to multiply everything by 2. So that is 2 times 25, that is 50. Then cancel out, so that is 4x plus 2. Combine like terms, we have, we'll transpose 2 to the other side, that is, it will become 50 minus 2 equals 4x. So 4x, you just interchange, that is 48. Divide both sides by 4 to eliminate 4 in x. So x is 12. So therefore, x is 12. Solve for x lang man. Okay? Okay, next. Theorem 2. If two inscribed angles of a circle or congruent intercept congruent arcs of the same arc, then the angles are congruent. So already discussed this, no? Kaganina, if they have the same arc, for example, in figure 1 below, the PTE, and PLE, no, they have the same intercepted arc. It follows that their angles are also congruent. In figure 2 above, GSO, and RMP intercept GO and RP respectively if and only if GO and RP, okay, the same na sila. Okay, lesson 4. Proving theorems on angle inscribed in a semicircle and quadrilateral inscribed is a circle. So if an inscribed angle of a circle intercepts a semicircle, then the angle is right angle. So, ato na na-discuss kanina, no? In the figure on the right, angle ABC intercepts arc ASC. If ASC is a semicircle, then angle ABC is a right angle. So meaning, the right, the figure on the right, angle ABC, meaning angle ABC intercepts ASC, diba? Na-intercept na niya. And this ASC is a semicircle, diba? Therefore, this is a right angle. Why? Because the measure of one semicircle is 180 degrees. So based on the theorem, no, the measure of the inscribed angle is half of 180. So half of 180 is 90, and 90 is the measure of a right angle. So there, that's why we have 90 degrees. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So na-discuss na to ni ganina. Quadrilateral oval, OVAL, inscribed in circle Y. So, angle VOL, meaning VOL, this VOL, and VAL, meaning they are supplementary, meaning the measure of this plus the measure of this is equal to 180 degrees. Then, OLA, meaning OLA, this one, plus OVA. Okay. That is for inscribed quadrilateral. That's all for module 5. No? That is just proving of our previous theorems in module 4. Okay. So that's for your activities. Please refer to your to-do list. Okay. That's all for our module module 5. Thank you so much.